Alrighty, so we've been learning about set notation and how this links to Venn diagrams, and we've also looked at how Venn diagrams link to two-way tables. So the title has gone somewhere, not sure where, but our title will be Using Arrays for Two-Step Experiments. So an array is basically a table, a graphical way for us to show possible outcomes within a probability experiment. So to begin with, we're going to have a look at this little situation called Is It a 1 in 3 Chance? So we've got Billy, and he's tossing 2 coins on the kitchen table at home and asks what's the chance of getting 2 tails. His dad says that there are 3 outcomes. You can either get 2 heads, 2 tails of one of each, so there's a 1 in 3 chance. Mum says that with coins, all outcomes have a 1 in 2 chance of occurring, so she thinks there'll be a 1 in 2 chance. And Billy's sister, Betty, says that there are 4 outcomes, so it is a 1 in 4 chance. So can you explain who is correct and why? So let's start off with who's wrong. Let's have a look at Mum. So Mum says that there is a 1 in 2 chance with all coins. So when we're just tossing 1 coin, yes, they have a 1 in 2 chance. You can either get heads or you can get tails. But that is not what is happening right now. We are tossing 2 coins, so there's actually more than a 1 in 2 chance. So Mum is incorrect. So let's cross her out. Our next one is, let's have a look at Dad. He says there's a 1 in 3 chance. And then Betty says there's a 1 in 4 chance. So to see who's right out of those two, I've done up a little table depicting the coins. So coin 1 can either get a heads or a tails. And coin 2 could also get a heads or a tails. But we also know that there can be a combination of both a head and a tail. So we're going to do heads and tails. Oop, I did them around the wrong way. Tails and heads. So what can actually happen is we can get a double head, a double tail. Coin 1 can get a head while coin 2 gets a tail, and coin 1 gets a tail while coin 2 gets a head. Now, it is tempting to say these are the same. But the question is, are they really actually the same? The answer is no. So because coin 1's getting a head in that first situation here, where coin 1's actually getting a tail there. So even though they give us the same result of 1 of each, they're actually different because coin 1 is producing a different result and coin 2 is. So in this, we would say Betty is correct because there is a 1 in 4 chance. We're going to look at this a bit later on, but I'll quickly show it to you now. You could use something called a tree diagram. So we're going to have coin 1, coin 2. And what a tree diagram is it actually maps all your possible outcomes. So coin 1 has the options of getting a head or a tail. And there is a 1 out of 2 chance. So if we add both those probabilities together, we'll end up with a whole, which is what we want when we do probability. But then we draw our lines from coin 1 to coin 2. And coin 2 has head or tail, head or tail. So they're the possible options. So we actually then put a outcomes on the end. So, I forgot to put in the probabilities. They've all got a 1 in 2 chance as well. So I'll use a highlighter for this. So if we're looking at our first string, we start here, we get a head, and then we get another head. So our outcome would be head, head. I'll use a different color. We're now going to we get a head, but then we get a tail. So it's going to be heads, tails. We're then going to go a tails and a head. And finally, we'll go blue. We're going to have a tail and then a tail. So they match up to what we just did in our table. But then the really cool thing about when we do tree diagrams is because we've assigned all these probabilities, we can actually multiply them to find a certain outcome. So I haven't left myself a lot of room here, so I'm going to go back up the top. If I want the outcome of tail, tail, I start here and I go to my first tail. And its probability is a half. So I'm going to write a half. I then multiply it by the probability of our next option. So I'm here on my tail, and I want to get another tail because I want 2 tails. Again, its probability is a half, so we multiply a half by a half. 1 times 1 is 1, 2 times 2 is 4. There's our 1 in 4 chance, like Betty said. You don't have to worry too much about these tree diagrams right now. We are going to look into them a bit later on, but I thought it might be useful to see that there are other ways to do it, and personally, I find it easier to use tree diagrams. But let's jump back to arrays and have a look at our notes. So, an array or a table is often used to list the sample space for experiments with 2 steps. So our key words here is array or table. They're the same thing. They list our sample space and for experiments with 2 steps. So remember, our sample space is possible outcomes. And our experiment with 2 steps means we're doing something where we do one thing followed by another. When listing outcome, it is important to be consistent with the order for each outcome. So, consistent with the order. And the reason for this, if I flick back, is we can see that if we switched our order with our coin situation, we could end up with only getting 3 possible outcomes. So for example, the outcome heads tails is different to the outcome tails heads. So the order in which it occurs is important. Some experiments are conducted without replacement, which means some outcomes that may be possible with replacement are not possible. So without replacement is saying, I have a bag full of marbles and I pull out a marble and then I don't put it back. That's going to affect the probabilities of the next draw of a marble. With replacement is I draw that marble out and then I put it back. Their example is the 2 letters are chosen from the word cat. So we've got our first choice, our second choice, and we've got cat, and we're doing it with replacement. So say I pull out a C, I can pull out a C for my second choice. Whereas without replacement, if I pull out a C for the first one, I can't actually pull out C for the second one. These notes you'll need to copy down. You can choose to print them if you wish as well. They'll be in your class notebook. I've gone ahead and I've put the worked examples in here. I've already drawn my tables just to save us a bit of time. So, 2 coins are tossed. We need to first draw a table to list our sample space, so all our possible outcomes. We then need to find the probability of obtaining heads, tails, and then we need to find the probability of obtaining 1 head. Now, an important thing to note in this is it just says 1 head. It doesn't matter whether it's first or second, it just has to be 1. So let's start with our 2-way table to list our sample space. I'm just going to zoom in a little bit. So what I've done is I have got toss 1, toss 2. When we toss a coin, we can get heads or tails, and same for our second coin. So when we're doing our sample space using a 2-way table, it's important to put our first one up along the top and then our second one down the side there. We will do a more complex one in the next example so you can see how this works. Another really important thing is we put brackets around that outcome with a comma separating the options. So what I'm going to do is I'm going to look at toss 1 and I'm going to start here with my heads. So it's going to be a H and H because that's my first toss, so we're going to list it first in the brackets. Same with our tails, it's going to be tails, tails, and then we put our comma. We can now go and fill out our second part of our brackets. So going across, our second toss will be heads, heads, and then we close our brackets, and then it'll be tails, tails, and then we close our brackets. I've now completed my two-way table for 2 coins being tossed. I'm then going to list my sample space. So remember, I'm going to use omega this time. Whoop, that's a bad one. It is going to equal, then we do our squiggly brackets, and then within our curve brackets, we list all our possible outcomes. So we can get heads, heads, tails, heads, heads, tails, and tails, tails. And then close my squiggly brackets. So I have now drawn my two-way table and then listed my possible sample space from this experiment. B is then asking us to find the probability of obtaining a heads or a tail. So from this we can see there's 1, 2, 3, 4 possible outcomes. So I'm going to do my probability of a head tail is equal to something over 4, because we have 4 possible outcomes. Now remember, order is important, so we're looking for a head tail specifically. So head head, that's out, tail head, that's out. There's my head tail, and then tail tail. So it's just going to be 1 out of 4. For C, it's then asking us the probability of 1 head, so I'll do my probability 1 head. Now, this doesn't specify an order like our part B did. So all we need to do, I'll change the colors so that we know the difference. We just need 1 head. It doesn't say at least, it just says 1. So looking through this has 2, so we can't count our first one. 2 has 1 head, so we'll count that. 3 has 1 head, so we'll count that. And 4 has 2 tails, so we can't count that. So, whoops. Nope, don't want to highlight that. Delete. So we still have a total of 4 outcomes, but now we have 1, 2. We can then simplify this down to a quarter. So we're able to find our probabilities and sample space quickly using our tables or arrays. All right, let's do our last example. So this one's a little bit more complicated. I've gone ahead again and I have drawn our table. Now, something I should have noted was this was with replacement. Because it was 2 separate coins, it automatically becomes with replacement. So this one is without replacement. We have got 2 letters are chosen at random from the word tree without replacement. So they may have written these on bits of paper and then put them in. We need to first list the outcomes in a table, find the probability that the 2 letters chosen are both E, and find the probability that at least one of the letters is an E. So I've gone ahead and I have done my first along the top and my second letter drawn along the side. Now I'm going to go and I'm just going to put in I'm going to zoom in a little bit. I'm going to put my brackets in for all of these. Super important to remember brackets. It's just a part of our mathematical communication and the process, so it's not something you want to forget. I'm then going to go down each column. So remember, columns are our first draw, and I'm going to add that letter. So it's going to be T, 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 R, 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 E, 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 E. But one thing that we've got to remember is that this question is without replacement. So what that means is if I've drawn this T, I can't draw it again because I'm not putting it back. So I can rub that out and I'm going to change it to red, and I'm actually going to put a big red cross in there because that's not possible. If I've taken the T out, I can't draw it out again. The same is going to happen with my R. If I've drawn it out once, I can't draw it again. It gets a little trickier when we get to these E's. So what I always do is the third letter along, so our first E, that's the same E as this one here. So we can't have this one, and then our 4th E and 4th E we can't have. So we're going to go through and put those red crosses in. It's okay if you've gone ahead and you've done them and then you've gone, oh, actually, that's not right. You can just rub it out and then put your cross in. If you've done it in pen, just put a cross on top of it. So it is important to always check if it's with or without replacement at the start. So now that I've put in my first letter drawn and I've also cancelled out any repeats that aren't possible, I'm then going to go along my rows, so my horizontal, and I'm going to add in that letter as the second. So it's going to be RT, ET, ET. Then we're going to have TR, sorry. ER, ER. Then next one's E, so TE, RE, and EE. Then my fourth letter is E again, so TE, RE, and EE. So now we've completed our two-way table. So now we've done that, it's not actually asking us this time to list our sample space. So if I go back to the previous question, it says draw a two-way table to list the sample space. So that's what we did here. But with this one, it just wants us to list the outcomes in a table. So that is now completed. Oop, where did it go? There we go. So now we're going to look at B. We want to find the probability that the two letters chosen are both E's. So what we want to do is I'm going to go through and count how many different options I have. I'm going to do these just in red in a little corner. So 1, 2, 3, 4, which I forgot to shut brackets, which is naughty of me. 5, 6, 7, 8, 9, 10, 11, 12. So there's a total of 12 options for this experiment. So I'm wanting to find the probability that both of my letters are EE. We know it's going to be over 12 because we've just counted. There's 12 possible options. I'm going to use my yellow highlighter and I'm going to highlight anything that is the option EE. So we're going to kind of look down the bottom here where we've got our E's, and there's 1, 2. So there's 2 possible options. But we then want to simplify this to 1/6. If you're not sure how to simplify, we're just looking for our highest common number that goes into both of them, which is 2. So I just divide both the numerator and denominator by 2. 2 divided by 2 is 1, 12 divided by 2 is 6. So the probability that we'll get EE is 1 in 6. Part C is asking to find the probability of at least one of the letters being E. So the probability of at least one E. I'll make that look like a 1. So again, it is going to be over 12 because there's a possible of 12 outcomes. Now, when it says at least one E, that means we can have either 1 times an E or 2 E's. So I'm going to swap my color of my highlighter to green, and in any of my possible options in my sample space with an E, I'm going to highlight it. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that gives me 10 out of 12. I'm then going to simplify this. So I know that 2 goes into both of these numbers. So 10 divided by 2 is 5, and 12 divided by 2 is 6. So the probability of me drawing out like an option that has at least one E is 5 out of 6. I'll upload this completed document onto Teams so that if you want to go back through and have a look, you can, but you can also pause this video throughout if you wish.